Well, what you got here is some curve
What's happening?
with the point. I'm just making a video for a student, Bennett. Just listen. With the x value -2 is what I see. And we want to find the tangent there at -2. And in method 2, we don't announce what the second point is. So that's going to be an x there. We don't know what that x is just yet. Now, how do we get these y values? Well, the answer is sub it in. Our function here is f at x equals 6x squared minus 4. So f at -2, I sub in the -2, I get -2 squared minus 4. And I get 24 minus 4. I guess I get 20 there. So I've got the initial point. So that's not so bad. That's just straight sub it in, and you could put that in your calculator if you wanted, to just type it in and find out what it is. Okay, so then after that you're like, well, okay, that's fine, but how do I sub in that x into the function? And that's actually easy, but it's weird looking. If I want to sub x into the function here, my value is 6x squared minus 4. Now I can find the secant slope formula. I go y2. 6x squared minus 4 minus y1, which is 20, over x2, x, subtract x1, which is -2. And maybe actually it'll help to actually write the slope formula, which is y2 minus y1 over x2 minus x1. Now this is very weird looking. And that's the difficulty of method 2, is that this is a weird looking formula. And all I've done is simplify it a little there. But then, once I have the formula, then I can make a much shorter table than method 1. I choose some numbers close to -2, say -1.9, -1.99. This is much closer than what I was doing in class. Sub those into this formula here and get the answers right there. See how that goes.